All right. We are live. All right, to give everybody a recap of where we are in terms of, like, where did we leave off last stream? And what are our goals? So last time, we got all of our UI layout stuff actually working, and text wrapping working as well. So, super happy about that. But that means that this stream, let's grab the same notepad from before. Our goals are, we got the text wrapping layout working. We got a builder pattern working for the UI elements themselves. Now it's time to template out some UI structure, potentially steal some colors from the Brane engine IM-GUI, and then we need to implement events and sources. And thinking about it a fair bit, what it has me thinking, like, reminded of is, what all this has me, brain. The way that, and I kind of hate that, this is the direction I'm actually, like, going in technical wise, but I think the way that Horizon Worlds does their UI makes a lot of sense for an MVP, if that makes sense. I mean, you get a ton of UI developers to make an engine. At least the UI is going to be good. It's actually really hilarious how much extra documentation they have for the UI system than anything else. Like, look at all these different sections on UI, and then if we look at literally anything else, like, let's say quest leaderboards, like, there's a lot less. Like, if I look at objects, like, here's the thing on, like, object hierarchies, object instantiation, which, like, there's a fair amount of stuff to object spawning and despawning, but there's not a ton of documentation on it. Ooh, actually, the greatest example of there not being a ton of documentation for stuff is if I go to scripting, events. Events are how basically all of their stuff works. Like, the way that you have things communicate to each other is through events, and they have, like, a single argument on it, and they don't even talk about network events. Network events just don't exist. They don't explain how they work. Yeah, but the way that the UI works, while pretty unergonomic, if we're being completely honest, the way that you actually define the UI in a semi, like, React based way with bindings actually makes a fair amount of sense. So if I look at, let me see if I can find a conditional rendering. Yeah, so there's, like, these UI if nodes. They have, like, the ability to functionally declare conditional UI. Ooh. And I like this idea of defining all of your UI as binding specific or binding dependent mappings or binding derived values. I really like this derived values concept a lot. So when we actually get to implementing state, I think changing values of nodes and the way, like, the layout of nodes, I think changing that through bindings makes a lot of sense. Now the question... This is my sign to lock in? Indeed, it is always a sign to lock in. Are you winning, son? I just need to lock in. So the question is, do I want to template out this UI structure before or after solving UI state? That is the question, because I'm thinking about, like, mouse events need state to act upon. And if I want to template out a UI that is dynamic, I kind of need UI to work upon. So let's solve the problem of UI state. So how do we make an event-driven UI? So when the real reason that I'm writing UI from scratch here, rather than using a pre-existing IMGUI framework, is because I eventually want to port whatever UI system I create into BraneScript and then script all of my UI using BraneScript. So eventually the BraneScript node graph UI will be written in BraneScript. This is entirely my plan, is to be able to script BraneScript within BraneScript. Recursive BraneScript. But that means that the way that you script UI needs to be compatible with a pure functional model. Or rather, like, events that... it needs to be compatible with events that take in UI, I guess. And for that, there are like two different concepts, two different reactive concepts, which one is layout changes, or I'll call it value changes, and structure changes. So value changes, we don't need to recreate the tree. And then structure changes, we do need to recreate sections of the renderable tree. And if we just say that, like, I'm just thinking about what structure should we use to scope changes to this tree. Because I don't want to recreate the tree of renderable things every frame. I would like to be able to recreate trees scoped to what changes affect it. Now, with the way I'm going to be designing UI currently, the UI won't change too much in too large of portions. Like, not everything is going to be governed by the UI system, the UI layout system. There's going to be some manual placement of UI elements not within a tree. So, what does this builder pattern look like instead? We need some concept of, I want to do this through lambdas and a lot of mapping. This means we potentially need to get into, like, derived macros and stuff. Because if I'm thinking about the way I would structure this, we would have something like a root level object through which rendering is controlled. That could be something like a UI view, and inside of UI view is like the UI element tree. Or all of the UI elements within this UI view, and the UI view might just be a UI element. In fact, it kind of makes sense for us to just keep the current UI element paradigm. And then this UI element needs to have a way to one needs to we need to update we have a resolve bindings pass we'll add in. Maybe not resolve bindings, but something to do with reading bindings. we also want the update layout. As per usual, except update, I guess update layout, I guess we can update layout if any of the bindings change. So we can update or resolve bindings, update layout, and also need something where we send events and events will hello. We'll have UI events. So a frame will look like this. We'll send events, and then we'll resolve bindings if need be. And then we'll update the layout of all the UI elements, and then also draw them if need be. So these are the two things we need to add: a send event and resolve bindings. And now we need the data within UI elements to be we potentially need the data within UI elements to be through bindings and whatnot. I am doing well today. We're reinventing React, but in Rust. And hopefully better. Closure-based reactive UI. Or bindings-based reactive UI. Event-based. All of that. Is the Windows Start menu actually made in React? Windows 11, yes. They did a conference talk about it. At React conference, they showed off, they bragged about the fact that the Windows 11 Start menu is React. Look, this is literally a React conference where they're talking about how cool it is they have React Native in the operating system. Yeah. I just can only make bad decisions, I guess. There's a big tech term. It's something I can't remember exactly. It's something along the lines of fungibility of developers. Let me search. I have an ex-Meta employee friend. And like one big thing at Meta is apparently the like fungibility of developers. Let me find the exact term. Anyway, I think it is called fungibility of developers. And I'm guessing that Windows is also following suit, but the idea is, if everything is written in React, any developer from anywhere can work on anything, right? And then, like, yes, this senior developer is perfectly capable of being a senior developer on anything, and this will have no problems, ever, because people all have the same exact skill sets and are interchangeable. Yeah, fungibility, I think, or non-fungibility. Meta fungibility of devs. Okay, there's no immediate Google search. I guess it's mostly an internal thing. Okay. Why is there... Okay, I guess that's just a drawing error. So there's two ways I can go about this. Make it so the UI element itself is entirely reliant on bindings. Like the construction of this builder here, make that entirely reliant upon bindings. It's also a bit silly to assume that every developer is automatically competent. Oh, but if you hired them in the first place, obviously they're competent, right? That's how this works. So one thing I could do is just be like, have like a list of bindings and then a closure that sets values from those bindings and recreates this UI element repeatedly. That is a possible solution. Like, just recreates this entire UI element. don't necessarily want to recreate the entire UI element. I do kind of like the idea of having a IAM GUI based system. IAM GUI-esque system where you just scope IAM GUI like different intermediate mode areas to different areas. So what we could do is completely change it from the way it currently is. Have it be lazily updated. Okay. I have an idea for something that could potentially work. And I kind of am reminded of how the parser I use works. And let me kind of template out a begone viewer bot. Yes, I think this is the way we're going to do it. So the way that we're going to construct UI elements now is going to be by passing in bindings. Not bindings to values, but essentially like constructors for things. And we'll have 3 different bindable constructors for each UI element. So UI elements will have a content constructor, there will be a content binding, a layout binding, which just returns the current layout of the structure, and we will also have a children binding. And each one of these bindings will be in charge of tracking their own changes. So the way that a binding will work, best practice, you should create a basement structure. No, this is Florida. We use an attic. We don't have basements. We have attics. We'll just call it container for now. There you go, UI container. That's what we'll call it. The UI container. Because I do actually need a split of like an actual rendered UI element and a like container for elements, because there could be two different because text is fairly different in terms of cached data. This entire system I'm about to create now has a lot more potential for caching than systems I've made previously. So the UI container contain, I think that's how you spell it. We have the content binding, or is that content or would the children binding be part of the content binding? This is the question. I think content binding background text yeah, this will be the background, the text, and children elements, child elements. And then, yeah, a layout binding and a content binding. See, the thing is, this will also need a cached element, the thing that actually stores the resolved values of the layout and everything. This will also have event listeners here. Yee. And then whenever we go to draw this, that's when it will lazily evaluate all the content bindings and just everything required to actually, generate data. So, how are bindings going to work? Because obviously you might need multiple pieces of data to actually generate some content. And when creating the content... Oh, I forgot. A draw binding? Question mark? And of course, the draw binding is dependent upon the resolved layout tree. And then do I actually need a content binding if I just have a draw binding? I guess we would still need, like, the children. Then again, that could be part of the layout binding itself. The layout slash style. I guess children is part of the layout. Then we could have a draw binding here. Man, something's up with why does it think that there's a... Ah! Anyway. Just reopen Vim, just in case. And then I'm actually going to create a new module here, and I'm going to call this Bindings RS. And this is just a type for creating lazy evaluated bindings. Which is a fancy way of saying, if any of the inputs to this change, the next time, it's essentially like, man, I have a different library in this project that is specifically for queries, and what I'm basically describing is a query system. But in the case of UI, it's going to be a little bit less whatchamacallit. So we're going to create a trait called binding. And this binding does it go here or there? I think it goes here. And this binding has a binding has a value, and I'm just going to say value is static. So this can only return stuff without a lifetime. And we have one singular method which is self, and that returns the value. I'm just thinking about, this is like the base level, this is just the interface that stuff needs to work with. This is what it requires. So let's just do the simplest version of a binding first. And the simplest version of a binding is just a constant binding, or do I want to call it a value binding? Static binding? I think I'm going to go with static binding. And static binding will just have just a value. And I'm also going to make it so that bindings must implement the clone trait. Values themselves don't necessarily have to implement the clone trait. But in this instance, values do need to be clonable. Actually, yeah, they do in this instance. Where value equals static and clone. And then we'll have an inner value. And then we'll make an implementation. We'll implement binding value for static binding value. This doesn't have type checking yet. Let's add this to UI. I guess we have to add it to main. I guess we could do a reference counted, but I potentially want to send bindings across threads. So here we'll just do self inner clone, and that will return a value. Oh, wait. We need to dereference before calling clone. Yes. So whenever we have a static binding, we'll just always return that value. Question is, do I want the value to be reference or by value? I mean, I could do different versions of this structure to where you could have static binding for value. If I say no, let's do copy. So we'll derive both clone and copy for this version of static binding, but here, if we have value plus not copy, Is there a way to say not trait? I thought that would define it only where this is true, like we could define different versions of it. I'm trying to like C++ template meta program this right now. Rust. I'm trying to micro-optimize this. You know what? I'm micro-optimizing. We're going for an MVP right now. Forget it. So we'll have a static binding here. And now that we have a static binding, we also need a dynamic binding. Actually, let me finish we need to do into binding. And then here we would have the value. And I'm just trying to think about what would a thing actually using these bindings look like. I guess the constructors for UI themselves, like UI views, like we can construct all of our UI through bindings, entirely through bindings, in fact. Or we could call it lazy, like lazy value instead of binding, and that would work as well. it would just be 2 binding, right? I think that's the Rust standard for this. So we would have a type binding, which is we would have a return type that implements binding value. See, I'm not sure if we can do a trait implementation, like an implied type here. Actually, I think we can. I guess it does perform a little bit of type erasure, but yeah, we just implement do a binding, we get a binding. So this trait is what we use in our arguments to functions. So now, if we want to do a builder pattern, instead of having to create a binding and pass in a binding to static numbers, instead what we'll do is implement value static clone. We'll implement a to binding for, and I'm just gonna say for a type. Actually, we can do for a value. To binding for value. To binding of value. And this will return static binding. Arc new, and then to binding should take one argument, which is self. So this will also take self, and when this self will be of type value, so we can just pass self into here. And now all of our builder patterns will automatically construct bindings if we pass in a raw value of a thing. Okay. So now we would be able to go through all of our UI layout stuff and replace them with bindings. But what use is that? Well, it gets interesting when we start talking about dynamic bindings. So if we do going to do a structure value binding, or we'll call this mutable binding, moot binding. Or, what's a good name for this? I kind of want to just call it binding, but binding is taken by the structure itself. If we're going moot and const, I'm going to go const binding on that. And then this will be our mutable binding. So our inner here, it'll be a arc. And we'll do, let's do a read write lock. Just in case, like, we're really using this data. And then, and also read write lock in case it's, like, recursively accessed, which I don't think will happen. Honestly, mutex is probably fine in this situation. But I just like read write locks, even though they're probably a little bit bigger. But for this mutable binding, what we'll put in here is we still need a value. There needs to be static plus clone. And now we implement mutable binding, or not mutable. Let's rename value here to just get. Binding get. So this will be get, and then we'll also method found clone for value. What? Oh, right. Mutex locking. So now we'll also implement mutable binding with a single method. Well, actually, we'll do two. We'll do new, which takes in a value. Ooh, one thing that I almost forgot. We actually need to implement 2 binding for the bindings themselves. That way we're able to pass them into places that require. So obviously 2 binding, it just returns themselves. Like, it doesn't do anything, but it allows us to pass it into the same fields. Okay, and then we'll have a public function set on this binding, which just takes in a new value. So when we set this, we need a reference to self, right, inner, right, unwrap. And the reason it's safe to just call unwrap on mutexes like this is the reason that you get a result from mutexes is, let's say another thread had a hook on a mutex and then panicked. That mutex is now corrupted. It will never be unlocked. So in those cases, unwrap, or the mutex, like, it's called a poisoned mutex. In those cases, this would return an error. But that means a different thread has already panicked, so I don't care about other threads panicking if one thread has already panicked. Self, right, unwrap. We're gonna say this is equal to value. And now the question is, how do we lazily evaluate things like this? How do we know when binding values have changed? Do we want to be able to subscribe event listeners to bindings? Or do we want to be able to pull bindings? I kind of want to be able to pull bindings. Perhaps we need the concept of a cached binding. Yeah, we'll call this cached binding, which takes in a value of static clone, well, no, because how does it tell? I guess a cached binding will just assume that upstream bindings are they're either cached themselves or can be evaluated every frame without issues. So we're gonna have a yeah. Create cached binding inner is a value of static clone. We'll just throw a derive clone on there. Actually, since bindings themselves are clone, we could have source just be... We don't need an entire inner struct quite yet. We can have source, which is just a... Oh. You can have value source where value is static in clone. But also source is equal to, or not equal to, but implements binding a binding to value. So now this atomic here I'll just do a regular mutex on this one. Since there's not really a way for... Yeah, we're just gonna reduce this to mutex as well. For now. There's not enough happening that are readable and writable mutex makes sense. At least quite yet. So now we need to implement just plain these two methods. Need to implement get for cached binding. And hopefully, very much hopefully, we don't get into situations with recursive bindings. I really hope that doesn't happen, because that would kind of blow everything up. So first, what we'll do if let sum value equals self inner lock unwrap I'm gonna say as ref or cache. That should be a reference to the actual option itself. And then I'm gonna try seeing if I can get away with another lock down here that doesn't cause it to be mutex lock, because this here should be scoped. Like, that reference should drop, right? Self cache lock is equal to you know what, screw it. We're just gonna say cache here. And like, I was being hesitant about just like doing a full scope guard here because what if, oh no, what if recursive dependencies? But no, if recursive dependencies were screwed, it already isn't working if there's recursive dependencies, so we'll just say if some value clone. Otherwise, we need to say cache is equal to dang it, this won't this won't be able to subscribe to updates. Which means we need to extend a binding to be able to represent the current state of the binding, I guess. So we'll put a version here. Yeah, we'll just use versioning for this because versioning is super simple, super easy. So for constant binding, we just return 0. And the reason we do versioning is because there might be multiple listeners to this binding, and all of those listeners need to store their state of if they've changed in accordance to this binding or not. So then here, in mutable binding actually needs to store a version here. And we could try doing a fancy thing where in the event that a binding has the equal trait or partial equal, I think it would be partial equal. It would need to be full equal, I believe, to work with this, but yeah, we would do... I always get mixed up. What's the difference between a full equal and partial equal? Because, like, partial equal is... I guess partial equal is something like, these two pointers hold the same state, but they are not exactly the same option. Where partial equivalence matters, so like, not a number equals not a number. Not a number does not equal not a number. I think partial equal is all I need for caching. Then, okay. And then I'm gonna do something fancy, which is conditionally implement this Can I say that this doesn't implement partial equal? Like, is this valid? No. Okay, if this does implement partial equal, then we want to check if value not equal to inner 1 then we increment the version number and continue onwards. But if there is no partial equal trait, then we can't bump the version number, only on changes. So we just implement that version of it. Dang it, let me do my thing. Oh, wait. What if I put them into the same implementation block? Can I say this is where like, you guys can see what I'm trying to do here, right? Rust where not implements rate. Okay, it only works for built-in traits. Yeah, see, here's a specialized implementation. They have the more specified version later, though. So maybe that's where I'm messing up. See, here's the thing. Big tech companies don't want to have to afford competent devs. They want to be able to afford... Or they don't want to have to afford senior developers. They want to be able to afford cheap developers. Oh wait, I had partially equal in the trait bound for that implementation. Oh, there's an unstable feature. It's called specialization. It's like I could have sworn I'd seen this before. Here's something that is merged in. It will say Rust implementation. As long as one of the blocks is clearly more specific than the other, the more specific implementation block is used in the case of an overlap. Design proposed here also supports refining default trait implementations based on specifics about the traits, about the types involved. Okay, so see, this is... Yeah, see, this is obviously more specific. Maybe if I moved this out into an actual where? Oh, wait a second, it's a trait. It's not necessarily members, it's traits. So I might have to create a versioned binding. A versioned binding Wait a second. Or no, a settable binding. Duplicate definitions with name set. Oh wait, default. In items in trait implementations. Dang it. So it does need to be... I do need to create a trait called settable binding. Or mutable binding, I guess. Well, see, then version. Version makes sense, but not necessarily setting either. See, there's very little overhead to having this here. I want to name this the mutable binding trait. But then we have the mutable binding structure here. Fine, I'm gonna call this mutable binding and come up with a different name for my main value binding. They seem to actively attempt to devalue those who normally would be expected of developers wanting as much experience. Yes. Yeah, the tides of the developer landscape are definitely seem to be shifting. Shifting away from high salaries. I mean, that's every industry is like make things cheaper, right? And the highest costs in any industry is going to be labor. That's just the truth. People are the most expensive thing in any industry. So, how do we make the people less expensive? Okay, so we now have a mutable binding here. Which means we're going to be implementing all our stuff. So I'm going to have these to be not... we don't... Nothing is harmed by these being public. We'll have a arc binding for value, where value implements clone, and this is where value implements copy. We're going to call this a copy binding. Arc binding. And the reason why I'm making those two separate is I want to avoid the memory allocation of this arc here. Ah, dang, I'm micro-optimizing again. Ah! This is all code that I plan to refactor entirely later. Why am I spending the effort to micro-optimize it? I guess it's a fun experience learning how systems like this work. And then for the copy binding, we don't actually have an inner trait. When we return value, we just return self-value. E. Rebound value copy. Okay. So here's where we get to have some fun. If a value that we've just passed as a to binding, if this implements clone and copy, we can return this as a copy binding without an arc inside of it. And then we just return value self. And then if there is a clone, then we need to do arc binding. And we're going to have the arc one be the default. What? Come on. Come on. Maybe I need to have an explicit where. I don't know why. It should just be syntactic sugar. And the order that things are defined in Rust files doesn't matter. Is the copy trait not enough of... both clone and add. Oh wait, do you need to put default on the implementation itself? Come on, let me specialize the thing! Oh, there we go. Yeah, and I can't specify not copy. Also, why isn't formatting working? What's wrong? Ah, here we go. Now formatting is working. Maybe that makes this start. Yeah, formatting isn't working yet, so somewhere in here we have a grammar error. No type value found for parameter source. Source is a binding though. Oh, get. Here, and I'm gonna just call mutable binding value binding. Okay. On items in trait implementations. Oh. Implement. We want to implement mute binding for value binding, where this equals a clone, but not partial equal. set shouldn't need a return value. Will this node graph system be also in-game, like Resonite's Protoflex system? Not initially. It's an eventual goal. Because the core idea of the language, that, like, switching it to a node graph system is like a refocus on this core goal, and the core goal is the representation of the language doesn't matter, it's the runtime and compiler that matter. So we could represent the language as a text-based thing, we could represent it as a node graph, we could represent it as like a cyan trigger-esque editor window. All of these different representations should be able to compile down to the same, like, higher level intermediate representation, and like send it through the same compiler runtime with the same like diagnostics that work for all the different things. So because of that, I would eventually be able to make a in-game system for scripting with this, or like an in-VR version. Now, does this mean you'll be able to go to any world and like press the equivalent of right-click inspect element? Probably not. Is probably going to be like an explicit, either you load up your world in dev mode, so you like set a dev tag, like dev toggle on your world, and it's like a developer specific instance of it, and then you load into that, and then the world has extensions, systems added into it to allow you to interact with the server as like a dev mode. Actually, this is like, I actually really like the way that Horizon Worlds has multiplayer editing. Now, there's a ton of bugs with it, and there was a lot of cases where we just ended up duplicating the project and then working separately in the two duplicated projects and then merging it back together. But I like the concept, even if it doesn't work in practice, because Horizon Worlds is the buggiest thing to exist. But I had the idea of, what if you have one editor instance, like a desktop editor instance of like just running somewhere, and then in that editor instance you're able to click the start server button, and then your PC starts up a server for the world in debug mode, and then if you join through the regular client into that world, it has injected systems into that world to allow you to hook back into the editor instance that's running on your desktop and actively edit the world. And then if you like either port forward that, or there's like maybe you run a debug server somewhere like in the on the cloud or whatever, people might be able to, like, your collaborators might be able to remotely join, and it would edit stuff on your PC, and that way you're able to still like version control and whatnot. But like, yeah. But I think it would be very much tied to specific, either specific clients. Well, it most definitely probably is going to be well, maybe not specific clients. It's definitely going to be specific server modes, and either server modes or builds of worlds that would have those. But for like a production release, you would remove all of those. Can you work with Protoflex in desktop mode? I guess, yeah, they do have like the desktop control rig. Here we go, set this version, set. Oh, this is like a member function, so we need to yoink this and make sure that we are in fact actually overriding this method. No! It's that form of specialization is unstable. What if I just implement the entire tray over again? Okay, that... Just let me do trait specialization. Implement this for this if the value meets these conditions. Yeah, it's open right now. See, here's the thing. Oh wait, this isn't this. Specialization is unstable. I want to use it though. I could have sworn I've seen specialization. Let's see, Rust. Maybe I can just do Rust metaprogramming. Yeah, specialization. Of course specialization would be able to fix this. would I have to manually do this for wait a second, if I just do arc here, the value needs to be cloned. And then we get back to where we were. I don't think they're conflicting though. Like, if it implements copy, do this one. Otherwise, do this one. Yeah, I could do an explicit value for let's see, Rust int type. If I do let test i32, can I see the definition of i32? Here's the implementation of int. I was looking at this because I want to see dang. Okay. We'll just have this here for that, but what we can do is no, because there's other copy types that I would want to not be in an arc. Dang, I know, I'm getting sucked into a rabbit hole. Okay, I have spent too long on this. I am putting the mental foot down. Everything is going to use arc bindings, and that causes me incredible pain because we don't need an atomic reference counted pointer there. We could just use a copyable value. But specialization isn't part of the language yet, so yeah. Back to actually getting stuff done. Conflicting implementations of the trait bootable binding. But like... Okay, even if I make them explicitly different like that, I guess I would have to put a type in here to like explicitly differentiate it. Which means, yeah, no optimization where we only increment the reference counter. When values actually change. Yeah, we can't actually do that. I thought I could have sworn specialization was a thing. Like, I'm definitely having specialization in Brane script to some extent. Then again, I was kind of thinking of having like constant expression based expansion of items in a graph. But yeah. Okay, so getting back to what we were doing, we have... Now with cached binding, we need mutable binding. Dang, and here's another place where, like, wouldn't it be pretty cool if we could do a version of cached binding where, you know, we don't have mutable binding defined for actually, since I can't actually cheese specialization by using traits, I'm putting version back on the binding trait. And now I don't have to do specialization of cached binding. It will just work for any binding. And then let's do... Source is equal to implement binding value, or rather to binding. Then we'll say let cache equal source get or rather sum source get. We always have a cached value actually. So cache doesn't need to be an option since we initialize it when we create this. Expected type parameter source, found associated type implement binding. Oh. There we go. No type erasure here. Oh, wait, because it's already a binding. It is implementing version. Screw you. Okay, and then this, we actually just want to do self source version and just like recursively chain version calls. So we're not actually storing the version within here. So changes trickle down the tree, I guess, from the leaves to the stem. So we do need to cache the current cache version, or the version of the cache that, that we have. So if our current cached version does not equal the current version of the actual source value, then that means that we need to grab the new version, which will say cache 1 is equal to self source get and then what we'll return is cache 1 clone. All right, and getting the value of a binding shouldn't increment its version. If it does, we have some very weird issues to debug. Recursive dependencies. That just means we have recursive dependencies. Okay, so that implements caching version-based caching for arguments. So, why do we need caching? So far we only have constant values. Well, that comes into play with what we're going to create next, which is a mapped value. Which we actually want to cache the result of a mapped value, so we might actually want to combine cached binding and mapped binding into the exact same thing. Because I'm thinking about it, and mapping a binding is the only reason why we would need to actually cache it. Like, even animated bindings. Yeah, okay. If I do go as far as animated bindings, which I might, to be honest. Animated bindings are cool. So, let's copy. Yeah, let's just change cache to binding into a mapped binding. And we're going to say f is a function which takes in an argument, so arg, and returns a value. Is there any situation where we don't want to cache the result of mapping functions? I don't think so. Okay. Up to find arg value. And then our source is going to be arg binding. Our cache is going to be the result of the function. And then our function is going to be the function implementing and that function also needs to be static, containing no references. I mean, arg value is never used. It's used right here. If I do that, does the where still work? Names that. Oh wait, it would be for the implementation that I put that on there. Let's copy this for the implementation. And then we don't need arg value. We just need that, and then we can say arg binding. Come on, how does that count as the argument not being used if it's literally being used in the function parameter itself? Or wait. Here's the thing. That needs to be... This now needs to be a type. You know what? I'm gonna ignore the type checker if it tells me arg value is not in use. It is. Screw you. New source. Source is equal to arg binding. And then we also need to take in the mapping function. Then we just return It's annoying that I can't do into binding, because the implement performs type erasure. Now, do I need to phantom data this? I loathe every moment that I have to actually use this. It's like, oh yeah. Create a type that gets removed at compile time to account for the thing that you know is in use, but like, the compiler needs to type check that it's actually in use, and you know, we can't make a better validator. Permanent solution. So then in here, imagine how existential it would be to not only find out reality was a simulation, but that it was a typed language, meaning everything about you would have been written out as data types. I would have more of an existential breakdown if I learned that the universe was written in a dynamically typed language, without any static validation. Like, the sheer amount of existential dread that would induce in me would be immense. But if I learned that we were running in a pure functional scripting language, with really good typing, then I'd be like, ah, my life was laid out for me before the program was even compiled. And there'd be a lot more certainty in that. Oh, right. We need to actually run the function on the result of source get. We need to actually map the thing that we're caching. Thank you, type system, for catching that. So we cache it once. And then let's copy this huge where block. Dang, I really do need to just copy this entire where block every single time. You know, for somebody who loves metaprogramming, sometimes metaprogramming in Rust can be quite a pain. But it's like, it's built very well for metaprogramming. Like, the building blocks are there. The ergonomics are just terrible. Half the time. The ergonomics of calling functions is amazing. The ergonomics of creating them is, like, when you actually want to do complicated things, is a lot more painful. So this is mapped binding, which means we do have F. No method named F found for reference. Mapped binding. Current scope. Does that work? It appears so. Well, just like that, do I have mapped, at least in the type system, I have mapped bindings working now, which means we have one last thing to implement, which, okay. We are now able to have an original value. We're able to map that value, so we're able to change that value, which means we're able to, from one source value, branch off and create multiple different expressions of the same value. However, what if we want to rely on multiple bindings? Well, now we need a way to combine two values into a single value. Oh, and real quickly, the way that I want to, I want to wrapping add. Is this a mutation? Does that mutate? I just don't want this to ever crash, because I can see that causing a panic at some point, because this is potentially an infinitely increasing value. And we don't necessarily, we just need it to show a difference. We don't need it to actually tell us like, oh no, it wrapped. No, we're expecting it to be able to wrap. We just need the value to be different frame to frame. Now we do our final binding concept, which is what I'm going to call the joined binding. And what the joined binding is going to do is yup. What this has is two sources. So we have a source 1, a source 2, value 1, value 2. I guess I do also need the types of the, I don't need the return type to be an actual argument though, because it's the result of these two. So this is binding 1, binding 2. And yeah. Binding 1, binding 2. No mapping function. Actually, I can get away with not needing to explicitly type the... no. Because I can't just, like, put binding in place since we are statically constructing this. Okay, so we don't need a phantom data. I think we actually might need a phantom data for... Because yeah, if I wait for this to type check, value 1 is never used. Value 2 is never used. Can I directly put just types in here? Like that? Okay, so we now have the data structure for joined binding, and now let's actually implement this. I still think that you should be able to, like, having generic arguments here makes sense for, like, generic arguments that aren't part of the type, but it should just be like you can define them as part of the type, or over here, and but then like, oh no, what if you slightly misname them? I could see that potential be a problem. But anyway, the binding that we will implement this for is for a tuple of value 1 value 2. So you see how you could just chain a bunch of joined bindings, and magically you'd be able to input into a function a bunch of joined bindings. So this is the way that the Chomsky, the parser library that I was using, works. And it's like a super elegant way of handling that. Anyone value 2. What do I mean? Trait bound binding 1 is binding value 2 is not satisfied. The trait value 2 is not implemented for binding 1. Yeah, I don't know. Anyway, version self. Source 1 version. Wrapping add source version. Or self source 2 version. Yeah, so now when either of these get incremented, it changes the version reported by the structure. Oh wait, map binding. We want this to be joined. That was the problem. Okay, good. I was gonna copy this real fast and do 2 binding for it. Binding. Delete all those. Okay, and now we don't need to worry about any of that caching stuff. We just do. We return value 1, value 2. Self source 1 get. And there we go. We have a versioned cacheable join between bindings. And I believe that is all of the building blocks we need to... Now we can have multiple inputs to a mapping function. That mapping function will correctly cache its input, or, well, it'll cache its output. And as long as none of its inputs change, none of its outputs will change either. And technically, this is clonable, so we can refer to it in multiple places as well. So we have a dependency graph of computation. For our, and we're going to use this for UI, but we could theoretically use it for literally anything. Even the compiler, even though what I was going to do compiler side was use a salsa style query system, which uses a database to make sure that your queries like, you never have overlapping queries. With this, you potentially could have redundant work, like a fair amount of redundant work, but not enough that we'd care about in like a UI system. With a compiler, you might have a fair amount of redundant work. Okay, what's wrong with value binding here? Okay, the last thing that we need to do is on binding here. We just need to create a couple template methods. So need to do map to we also need to do join. I think with, well, let's put join before map. So for joined binding, this is what we need. Oh dang, can I not use into binding? Binding should be binding should be statically typed, right? I do binding type and binding equals binding value. Does that make it so I can use toBinding? equals 2 binding What is it? Streaming right now. Apparently I forgot to lock my door. Not find binding type in this. Oh, self-binding type. Indeed. Ironically so. Not all trait types implemented. Type binding type. Here. I want to see the implementation of add. Come on. Code navigation work. We can do 2 binding value, but then type equals that. Does that satisfy it? Why do I have two implementations of this? Oh, right. And the reason I'm doing this is so I can actually use to binding and be able to infer what the actual return value is, as opposed to having it be implicit. Now, I wonder... No, because the arguments still aren't... I still wouldn't be able to do the thing I want to do with the... What is the name of the thing I want to do? Type specialization. Or method specialization. Still not able to get away with doing it. Null trait items implemented, missing type, binding type. Binding type is equal to... We have the mapped binding, we do self binding type. Actually, we can just rename this to type. Then we set type is equal to this massive list of things. Okay, now, anywhere where we take in a binding, now we're able to say wherever it is, aha, here. Instead of doing arg binding, we can do to binding type equals arg binding, and then in here, just say let source equal source to binding. And now this will autocast arguments. Release or work on any mods for games like Minecraft? Nothing released. I dabbled a tiny bit with Minecraft mods when I was younger. But never got anything more complicated than, like, here's a mob with a custom texture, or, like, some custom items that you can, custom crafting patterns. Really simple things, but nothing more complicated than that. Oh wait, this type will be implicit. Expected type parameter arg binding. Okay, maybe I can just explicitly say type is equal to arg value. Or, no, not arg value, arg binding. And that satisfies the type checker? Yes. That was joined? No. That was mutable binding. Do I have an implementation for joined binding? I don't. So I need to create that. Minecraft mods seem like they can get pretty complex. Could revisit if you feel like you need a breather project. My guy, this is the breather project. This is what I do when I'm not doing my job. This is a 2 binding value 1 type equals binding 1 b2 equals 2 binding value 2 type binding 2. There we go. Oh, no! Expected type parameter binding 2. Oh. Pretty sure this is my type parameter. Here we go. Expected type parameter binding 1, found type parameter binding 2. Ah, that would do it. So now we can do joined binding new. Oh man, this is going to be beautiful to see in action. Oh, wait. There we go. Now that's chainable. Now we get to do mapping. Oh, wait a second. I'm really glad my LSP filled that in for me. except for the fact that it filled in a binding type. I want this to be value 1, value 2, binding 1, value 2. So this is going to be value, other value, and self, then other binding. Or can you do that? Does that get the value argument? Or do I have to do... Okay, I'm going to rename this to V. Actually, no, we'll have it as value. And now, associated type defaults are unstable. Why? Okay, so I'm going to refactor this. So instead of this being an argument, it's a type. Like that. So now we can refer to the actual value in return things. So we just say value equals value, like that. Now I don't have to have two separate generic arguments on all of our things, because the trait, we can just grab the return value type from the trait. This will be binding type value equals value. Is it happy with that? It appears it is. So here in to binding, the return type is binding, where value equals value. Wait, but it's letting this do a default. Oh, wait, it's doing a... Yeah, that's a trait, not an actual default type. Okay, so now you get to figure out what the types of other things are going to be. I now understand why iterators are implemented the way they are, though. It makes sense. So here, we could just do value and arg. Actually, no. So mapped binding return value is the result of the function return value. Which means I do need that, but I don't need that. So we're going to say the return value, the argument binding, and the function. So arg is binding. And in this case, it'd be arg value. And you see how that like chains? So we don't have to put as much info in. And then the source here is just arg. And then we don't need the phantom data anymore. And now when we do to binding, binding is just for the value, right? So it'd need to be to binding arg value. Yeah. Okay. And associated type. Implement binding arg value be to binding value. That's our binding. Expected arg found associated type. Implement that type. Can I just explicitly say that? No, it does need to be a specific type. And is it not able to statically verify that wait a second, it's not complaining anymore. Why isn't it complaining anymore? Feel like it should be, but it's not. Okay. I'll take it. Implement binding for mapped binding. Morale of your code must have successfully improved. Maybe. Or it gave up. It's like, man, this guy is just gonna keep trying to do this until something works. We shall have pity upon him. This is a mapped value or mapped binding. All right. And now since it appears that mapped binding is happy, type system wise, that means we can go and mess with joined binding, which now, instead of having that huge argument list, we just can have B1, B2, because I think that's descriptive enough. And both of these are just a binding. Don't need any binding data. B1, B2. Actually, do I need type? I guess I would need a specific value or specific binding as my argument instead. Okay, where was I? Right, I was trying to figure out a better way to handle something. This. Because this pattern seems inefficient. Well, I guess it's only because we're needing to do type inference in these methods. Otherwise, we wouldn't need it. Ah! Go away! Yes, every single pass, my types get simpler. I am beginning to understand. Why do I have two? Oh, this is a 2 binding. Got it. I guess here I could just do self, right? Okay. And why these complain? It's because it's being used somewhere. Gotta find type. Self type. And now here, when I do 2 binding, that should be the same type, right? Or maybe 2 binding type is equal to arg. Just enforce that they are the same type. There we go. Okay, and now I can confidently say join this with other binding. And then we will have a joined binding between self and binding. Where binding is equal to binding. Oh. Nice. Never mind. Self B. Arc binding self. Why is that arc binding self? What's the return type of this? Join binding self B. Expected struct, but a found struct with joined binding, arc binding self. Why? Why is it choosing a specific binding type to put there? Actually, I'm going to say O. And the other binding, this is going to be a to binding instead of an implementing to binding. And then can I get the and we're going to say to binding this is going to be an other going to bind with the other type. Why is arc binding self sneaking in there? How is arc binding self sneaking in there? Implement 2 binding for arc binding value. Clicks with arc binding. Type equals arc binding value equals value? Okay, no, I do need a 2 binding argument. For this to work. Can you just say 2 binding? No, it's gonna complain that there's no type arguments. If I put V here... Let's say other type. And this will still Say that we found arc binding self. When we could have a number of other binding types. Like a wide array of other binding types. So why is it only working there? Wait a second. The arc binding is the first. The self argument is what's blowing up. The arc... So the... So we're evaluating self of, like, the trait self. The join binding. I don't want to have to individually... So what it's looking like right now is that I'm going to have to individually implement the join method on every single one of our implementations of value binding, which is not ideal. I'm just super confused. Why is self getting evaluated to arc binding? If I do that, does it solve the problem? The trait to binding is not implemented for self. Oh! Begone, viewer bot! The problem is that... Okay. You just clicked in my brain. There's actually a super easy way to handle this. No, see, it's not like stopping a toddler from crying. The toddler has no clue what they want. The Rust compiler knows exactly what it wants. Your code not to run. See, and we can do Here, implement B to binding for B where or we can just implement to binding for every single binding at once, and type will be equal to B and then Alright, and now I don't need to implement these traits. And honestly, this is what I should have implemented to begin with, is just a easy trait for just mass implementing to binding for anything that implements binding. And then this not that, this we actually need to be more specific for this. Value clone plus static, because right now it's trying to find every single type and just specify the type with the, yeah. We don't actually have, can I do this? Will that be valid? Wait, are you a bird? Yes. Come on, hand tracking. Eat. That's with the wings. It does need to be a specific type. So for some reason, now it's like, oh no, you have a generic thing. This must be cast to arc binding, because all generics must be cast to an arc binding. All of them. And you know, we won't even consider for a second that, like, maybe you should look at these and figure out Okay, I thought you were kind of like a progen thing. No, it's an Avali. Yeah. Locally known as space chickens. Actually, I'm not sure if that's a derogatory term or not. I just find it funny, so I use it. But like, I know of other friends who like don't like the term, so I don't know. I think it's funny. Like, why can't you just look at the trait? Look at the traits specialize. This is a very glaring issue. Anything that implements binding? These should count as two different types. Why don't they count as two different types? I guess I am going to have to proc macro this. Which I dislike. Completely defeats the purpose of two binding if the convenience wrapper kills the non-convenient wrapper. But like, if I go here and I go I-32, like this will work fine, because that's an explicit specialization. So I guess I just have to do use a macro rules to implement this for all basic scholar types. Let's see, refactor it so I can specify the binding type. And it's just now hallucinating binding types. So now what I'll put here is copy binding. And I am capable of getting this working. That should binding scholar type to binding. Let's look at the first implementation. Why am I not on streamer mode? See, it's an ident. What do you mean leftover tokens? Isn't this like a variable argument array? Or, oh, did the syntax of calling it change? It did. Nice. So now, let's actually implement a copy binding, because I can do that now. I'm forced to do that now. And now I need a way to actually we'll just do it per type. Type binding. This is going to be like that. And then we're going to immediately implement a macro for copy. And here, this is going to be copy binding. Then we're going to implement copy or arc binding for basically just string for now. Nice. Okay. So now I don't have to worry about wrapping any of these types, and if I ever need to wrap more types, I'll just add them to these lists. Okay, now that we have bindings, which are just lazily evaluated values, then what we can do next, the plan is simple. What we do next is we make UI function entirely through these. instead of the way it currently works, which is a strange amalgamation of both IamGUI and node-based. And we're essentially turning this into a you declare IamGUI style in an immediate style app. We're making React and Rust. I don't really need to explain it more than that. Okay, now I need to figure out how to refactor the current UI system to work for this bindings-based system. So I think what we need to do is create a builder, and then into that builder we throw in a bunch of bindings. We just throw a bunch of bindings into that builder, and then what we get out of that is a UI view or a drawable element. And that UI view or drawable element is in charge of caching any needed cached state. We essentially just call draw on it, and it works. And then it gives us the size of the UI and whatnot. Okay. I'm going to run real quick and then be back, and then we will implement that. And I'm actually pretty sure this is going to work pretty well. Alright, I am back. Are you ready to finish rewriting React and Rust? It turns out I don't actually dislike React. I dislike JavaScript. Reactive styles of programming are actually, pretty cool. Okay. Time to refactor all of this. So let's prototype out public struct. Whoa, why did I... Ow. Why is my headset recentering? It needs to stop doing that. So we have this UI view. And this UI view is a root UI element. One benefit of never mind, not a benefit. I was gonna say one benefit of this is we don't need references to elements anymore, but we do in fact need references to elements still, purely because occasionally we might need to request the position of a specific UI element, especially for node graph things. Like, position of UI element, very important. Unless we have the ability for okay, come on, it's not quite that bad. Most of the time. If you're smart about it, it doesn't get that bad. You should see my parser code though. Yeah, we do type erasure on that. So we have giant... We're going to create just massive, lazily evaluated structures. But what does that look like? If I think about it, we have the UI content, well, if I think about the dependency graph of data, instead of thinking forward, we have to think backwards now. So what do we want at the end of the day? What is the final result we want? We want a shape and a rect. So basically just a type of draw and the size, the place and size to draw it with. Or in other words, a draw function. Because, to be honest, that could be wrapped into one place. Now, what info do we need for this draw command? Do we want content to be changeable? And also, does this draw command... Yeah, this draw command is dependent upon... This needs references to child draw lists. So this will request, like, the binding that represents all the children for this object. So... what else is required for this? We need the draw commands for the children, which we will auto call after drawing this particular element. I think that rect is the easiest thing to reason about. This rectangle is the result of this, which the result of that function is this, which is the result of this function, which is the result of this function, which is the result of this function, which is the result of that function. And all of those functions require a little bit more info, which is basically just all these need a layout tree. Like, this is recursive, requiring either the results of parents or the results of children. So if we were to call compute positions on an object, it would recursively call compute positions for the parent. And once it got up to the beginning, you would need to call compute heights, compute fit heights, compute wrap, compute widths. And I'm not quite sure how to abstract this into an event-based architecture instead of the single pass that we're doing right now. I guess I could start by reducing each one of these functions into its own event graph. So instead of, like, you know, just jumping the gun and immediately, you know, creating a thing that works the way we expect it to, instead, let's try piecing this together piece by piece. We can do... We have two different layout types. We have container layouts and text layouts. I'm trying to figure out if there's a way to... Is there a way to make it So let's say we have this tree. And let's say, for reference, that this element's width changes. Let's say that this is a fixed size. If this is a fixed sized element, and the size of this element changes, and let's say that this is a fit container. I guess it also depends on which axis it is. So which axis it is depends on which, I guess, results in which bindings result in what things happening. Man, this is going to be an absolute nightmare to debug if I don't get it working correctly the first try. So, let's create we have a UI element builder. What is actually needed from this builder? When we create the UI, we should do, after we've actually created, the layout tree, there's one extra pass that needs to happen. Oh, wait a second. I have one last binding type I need to create, which is not a mapped binding, but I'm gonna call it a what should we call this? If you live compute a binding. We'll just call it a function binding for now. And the difference between this and a mapped binding is that it takes no arguments. Wait a second. If it doesn't take any arguments, what's the point of it being a function? Yeah, we don't need this. Okay, what was I thinking? Was the Haskell in him talking? You don't know half of it. I haven't actually tried out Haskell, but functional programming is where my brain is at right now. Okay, we need to split this up into passes. So the first pass is when we're actually creating the UI. We need to take in... We do need to take in the content type. Like, what is actually being displayed. And we need to take in... So we have our content. We need to also take in layout information like styling. The content is the style. The layout is how to position it. So in a sense, content is kind of a draw command, if we're being completely honest. Like, it could be refactored to be a custom draw command, but let's try keeping changes to a minimum, because I have 2 days other than today to get this working. So we just need to get this actually working. Yeah, so let's just go gung-ho on refactoring the system that we currently have, but start at the builder level. So content, let's make this a this associated type never has a where self-size bound. And while the associated type can be specified, it cannot be used. binding is not dynamic compatible. I'm guessing that's because maybe of map, which I realize I never finished implementing. For a trait to be dynamic compatible, it needs to allow building a vtable. How do I allow building a vtable? What if I remove that? Oh, wait a second. I know what's going on. Yeah, the problem... The problem is that we're returning self... No, it's not that we're returning self-value. Value is known. Version is known. If I remove the clone trait, does it become dynamic compatible? Consider moving join to another trait. Ah! I want to chain the joins, but I can't. Fine. What I'll do is we're gonna create a macro gonna call this binding ops. And to be honest, they don't even need any arguments. We can write this in such a way that is literally not type specific and should be able to go in something like a trait definition defining, you know, arguments. I'm still like relatively inexperienced with Rust macros like this, so it takes a little bit of messing around with it. But we're gonna throw join in here. And then I'm gonna prototype out map on okay, so we have join implemented for this. We know join works, so let's do map, and what we need is mapped binding. We take the value, the argument. The value is our output. And then the function. So self we basically need everything but the arg. The arg is us, or self. I think self value word. No. Come on, get out of my way! Get out of my way! Thank you. Actually, I'm gonna keep that as fully qualified just in case. Then we're throwing this into our macro. And then this implementation here okay. And now value binding, implement value binding, implement our binding operators, map binding, implement map binding, throw our binding ops in there, join binding. Okay, now they should actually be chainable. And also dynamic compatible, which is a big plus. Let's see, the thing is... I want to be able to statically handle this. But I don't think that's going to be an option, unfortunately. This is the best we're gonna do. Boxed binding. So our rectangle... wrap text, layout, even the children. Would even on event be... How would on event work? In this new system, I'm kind of thinking... Okay, if I do a... If I have this public builder, and then this is going to be a boxed UI element. So then UI element is going to have a function call, which is just refresh or update or even draw. Let's see, the system that I'm basing this off of is supposed to be able to do it. There's like some unique trick they were able to pull off to inline these calls when it was like functioning as an I am GUI style. Which, to be honest, if I can I am GUI style this, that would be amazing. Actually, that doesn't really matter at all for the current way that we're implementing this. Okay, so my main concern right now is this layout pass. And what we need is honestly, the main consideration here is text. I don't have a way to handle text currently. So if I can split text off into its own system, that fixes the majority of our problems. Okay. And now we basically need UI element when I do self compute fit widths. I basically need to return a binding instead of, yeah. Okay. So our new UI element is going to be I'm going to compose it as a trait. It was inevitable. It was gonna happen eventually. Hopefully I can get away with this not being only a trait, but being an actual data type, that we were able to put stuff in line. But what UI element needs is bit width will return a binding that is equal to the value of this is really just an F32. Like, literally, give me the fit width of this element. Like, from the fit width pass. So I'm gonna make this its own trait called UI layout passes. Just to, you know, template it out. Dynamic width. And we're not actually going to make this a public pass. Okay, our text height sizing will be like implicitly added here into this binding here from the results of the other two. And we compute fit heights. compute the dynamic height of this object. Which, to be honest, this could be simplified to just width and height. And then we can implicitly generate all of this from bindings. Like all of it. So let's attempt to do that for see, we have new text as its own separate thing. So let's do a UI shape element first. Ooh, and here's the interesting thing. For width, width requires access to... Oh wait, I can have those be bindings. I can have all of those be bindings. We don't need to worry about that. I'm not gonna worry about that. Not gonna worry about any of it. So let's make layout. Layout is easy. Layout is a source. Actually, no, let's not have layout be its own separate thing. Let's just bake it into the elements. Why is it acting weird? Expected an item. Here we go. So this shape, hub shape, this is going to be a UI, not container element, but let's call it, yeah, UI container. And then this will be background. Yeah. Yeah, and this is going to be a value binding. And thus the bindings begin. So these are the bindings you can use to mess with the actual state of this element. The inputs and whatnot. Theoretically. This will just be a builder for now, which means technically, here, I'm going to create a boxed binding type. And all this is going to be is a type erased version of a binding. See, and then to our list of binding operators, I'm going to add boxed. Bound B1 bindings value clone is not satisfied. Actually, I don't really need to put any requirements on that. Implement binding box. Value hub function new, and this just takes in one binding which implements anything that implements binding. All right, and now we just implement and just like that. We now have a version of binding where we don't need to worry about what it actually is. Which is exactly what we want. Those are all our bindings for the actual like inputs to the appearance of our element builder. And we should have an on event as well. We should also have a rect. This rectangle, or binding box, So basically, here are our inputs. And this is our output. Right here. Or at least one of the outputs. Hello. What does it mean? Parameter type arg may not live. Ah. I guess, yeah, I can enforce those type constraints on everything. Or lifetime constraints. That our bindings must be static. Binding type V may not live long enough. Which means we need this to also be static. Means we may also need this. Okay. All of that should be good now, I guess. I'm kind of getting deer in headlights with like just how much boilerplate this is gonna be. But let's just... let's refactor our current builder. And just, for the moment, forget about text. Where did UI element builder go? Oh, because this is UI element. And I was making a build. Okay, yeah. Content. And I do want to keep... I do want to keep the same structure for both. I'm gonna do new shape, UI shape. Okay, and content is going to be and how do I want to handle child elements? Gonna ignore events for now. I'm not sure how to handle children, though. I know. Here's what I'll do. Maybe. I don't think at any point I actually get children by index. No, having a vector of them is good. But since we don't actually need references to children anymore, instead what we'll do is have... Because even if I do need references to any of their properties, what I should do is get bindings from them. Ooh, do I want to do a binding of bindings? Every possible thing that could possibly change. Wait a second. Yeah, I should probably do that by value like that. That makes sense. And since they're one-time allocations, it's not like we're doing a vector every single frame. I think. Probably. Alright. I am really slowing down, so I think I'm gonna go scarf down some food, and then... Yeah, these are problems that are best solved off-stream. But yeah, to those of you who stuck around, thank you very much. And I will see you tomorrow's speedrun stream. Alright. Come on, hand.